Hello! So this is our last video on vectors, which is all very fun. And it's only got one thing in it. It's a thing called the dot product, otherwise known as, aka, the scalar product. Okay? So we know how to add vectors, subtract them, and we can multiply them by a scalar. So we can just do 3 lots of it, or 5 lots of it. But what we don't really have yet is a way of multiplying 2 vectors together. Okay? That's what we're going to do now. So let's have a think about it. Let's think about how we can do it. Then there's a cool fact about it. We can use it to find angle between vectors, and we can expand brackets with it. So how can we possibly multiply 2 vectors together? Well, we need 2 vectors, don't we? So, okay, here's a vector A, 3, 4. Here's a vector B, 2, minus 1. Okay, there's 2 vectors. What is the simplest way you can think of to multiply these together? Okay, well, what you could do, same as with adding, is you could times together the 3 times the 2, and you could get a 6. And you could times together the 4 times a minus 1, and you might think that you'd get then a minus 4. Okay, now that's the problem is then interpreting it. What do I do? So adding vectors is very easily. What I can do is I can follow one, follow the next. Multiplying vectors like that, it's very hard to interpret what that means. It's not clear what that could be. So what we're going to do instead is we're going to kind of do that. But what we're going to do is we're just going to get these 2 numbers here, and we are going to add them up. 6 plus minus 4 is going to be 2. So what we've done to work out the dot product with this big dot here, okay, what we've done A dot B, and what we're going to do is we're going to do 3 times 2, the top ones. We're going to do 4 times minus 1, the bottom ones. And then we're just going to add those 2 things together. 6 plus minus 4, so 6 plus minus 4, which is 2. Okay. Now, why just add them together? What does that do? Well, actually, it turns out there's a super cool fact about doing this. And if I do A dot B, like that, 2 vectors, dot product times together like this, then the answer I get is the same thing as the length of A times by the length of B, so magnitude is the posh word, remember, magnitude of A times magnitude of B, times by the cosine of the angle between them. So in this case, A was 3, 4. What does that do? It goes across 3 and up 4, kind of like that. B was 2, 1. So what does that do? It goes across 2 and down 1, so kind of like that. Okay, and what do I have when I work out A dot B? I've got the length of A times by the length of B times by, if I were to sort of carry them on, this is the angle between those 2 vectors, okay, and cos of that angle is a number that you can work out. And so you multiply the size of that by the size of that by cos of that angle, and you get the same answer as if you'd done times the cos top times cos bottom and add them up. This is super, super cool. It's super, super useful, and it's super, super easy to do. Okay, so what can we do to kind of explore this a bit more? Well, for example, just in case you don't believe me that this works, let's try a simple one. Let's do A dot A. So practice. This is a really good thing just to practice doing. A dot A, so A is 3, 4, dot product with 3, 4. 3 times 3 is 9, plus 4 times 4 is 16, which is 25. And apparently, it's supposed to be the magnitude of A times the magnitude of A times cos of the angle between them. Now, the magnitude of A is, well, what we do is we do 3 squared plus 4 squared, and we square root it. So that's to get the length of A, the magnitude of A, which is, as we all know, it works out to be 5. Okay, so what I'm going to do is I get the magnitude of A, which is 5, times by, we're using dots for times these days, 5 times 5, which is 25, times cos of the angle between them, and of course A and A go the same way. The angle between them is 0. And what is cosine of 0? Well, it's 5 times 5 times 1, which is 25. Okay, so what have we done here? A dot A, do the process, you get a number. Okay, remember you get a number as an answer to when you times these two together. And it just so happens that matches the length times cos of the angle between. Now, what that means is that we can find out whether vectors are parallel or perpendicular or other things. We can find out the angle between the vectors by working out using this formula. So, for example, what is the angle between A and A? Well, we know that A dot A equals 25 equals mod A cos of the angle between them. We worked all this out, which is 5 times 5 times cos theta. And if we have 25 equals 25 cos theta, we can divide by 25 and get 1 equals cos theta. And we can do our inverse cosine of 1 to find out that theta is going to be inverse cosine of 1, which is in fact 0. So the angle between A and A is 0. Okay, and what we find out basically is that A dot B, two random vectors, is going to equal the two lengths multiplied together only if, or if and only if, A and B are parallel, if the angle between them is 0. Because that's the only time you get cos of 0 equals 1, cos of nothing else equals 1, apart from 360 and stuff like that. So, this is a fun little fact. You don't need to remember it. All you need to do is remember this. This cool fact is the only note for today, really. It's super duper. That and actually how you do it. So times, and add. Okay? And obviously a special case of that is when theta is 0, cos of 0 is 1. And you just get A dot B is mod A mod B. Like it says there. Okay? What other special case is there? Well, let's have a look. Let's play with B. B feels a bit left out. B is 2 minus 1. Now, you might remember from straight lines, I hope you remember from straight lines, that if I wanted to find a perpendicular gradient, so if I had 2 over minus 1 as a gradient, and I wanted to find a perpendicular gradient, I would flip it and get minus 1 over 2, and then I'd flip the minus sign as well and get a half. So minus 2 is perpendicular to a half in gradients. Similarly, you don't have to know this by the way, but it's just, gives us something useful. A vector that's perpendicular to B, so let's call it P for perpendicular, is 1, 2 as a vector. So, what do I get if I do B dot P? Well, I do 2 times 1 at the top, which is 2, add minus 1 times 2, which is minus 2, which is 0. And here's another consequence of the same fact. See, when theta is 90, if two lines are at 90 degrees, they're perpendicular, they're at right angles, then cos 90 is 0. 0 times anything is 0, so A dot B is going to be 0 if and only if the two vectors are perpendicular at right angles. So because B dot P is 0, we can straight away say therefore B and P are perpendicular, they're at right angles. The angle between them is 90 degrees, perpendicular. Great. Final example, let's find out what the angle was here between these guys between A and B. Well, we worked out A dot B, we can do it again for practice. So here we go. A, that was the vector 3, 4, it's not a fraction. B was the vector 2 minus 1. Okay. therefore A dot B is 3 times 2, which is 6, plus 4 times minus 1, which is minus 4, which is 2, which is the same thing apparently as mod A, mod B, length of A, length of B, magnitude of A, magnitude of B, times by cos of the angle between them. I'm going to try and find that out. I also know, by the way, remember up here we found out that magnitude of A is 5. We can also do the magnitude of B, which is going to be from here, 2 squared plus minus 1 squared, so 2 squared plus minus 1 squared, square rooted, 4 plus 1, which is root 5. Okay, so let's have a look. That's fun, isn't it? B is half the length of A. Okay, that doesn't make sense. Anyway, let's work it out. So mod A, sorry, the length of A was 5, so that should equal 5 times by root 5 cos theta. So I can work out what theta is because I know that 2 is 5 times root 5 times cos theta. So cos theta is 2 divided by 5 times root 5 all at once. And that on my calculator, which I will just go and grab. There we go. So 2 divided by 5 times square root of 5. Oh dear, my apologies. Okay, if we've got a number for that, that's this. I can get a decimal number, 0.17888, right? Anyway, I'm going to do the inverse cosine of my answer. And I find out that theta is, can you see that there? 79.7 degrees. Theta is 79.7 degrees. Okay, so that's what's happened there. And then we can look back at our picture. Is that about 79.7 degrees? Yeah, I can believe that. Looks about right. Okay. Something to watch out for. Last little thing to mention, let's use the back of this. So when I'm doing a dot product of two different vectors, if I've got two vectors that go more or less the same way, I'm going to get a positive dot product. If I have two vectors that go right angles, I'm going to get 0 dot product. If I have two vectors that go kind of like opposite directions, I can still work out that angle there. But what's going to happen is I'm going to put it in my calculator. My calculator is actually going to tell me this angle here instead. So to work out the angle there, the big angle between two vectors that go in kind of opposite directions, I'm going to have to end up doing 180 minus the angle there. What will happen here is the dot product will actually be negative. So what will happen is you'll put into your calculator the negative angle, and depending on the calculator, it might straight away tell you a nice obtuse angle, or you might have to do 180 minus it. If you get like this, it might tell you like say minus 30 is the answer. You'd have to work out that it's going to be 180 minus 30, which would then be 150 is the real answer, depending on the calculator. Okay, so if it goes kind of the same direction, two vectors, we get a positive answer. We know it's 0 when they're perpendicular. The dot product will be negative for two vectors like this one and this one that go kind of opposite-ish directions. You have to be careful because you're going to get told a negative answer for the angle, which you might have to work out, most likely. Great, have fun.